Hello, class. This will be our video for fractions, which is the R2.1 and the section 5.3 homework, your second homework. This will be a little bit longer video than normal because there are a lot of things to cover in fractions. Unfortunately, fractions are something that a lot of people struggle with. And so I will say I don't have time to reteach fractions completely. I'm going to try to hit the high points, and then we'll go from there. As always with my videos, the basis for which I will be working through examples. If you go into Blackboard, right now we're still in Unit 1. So if you go to Unit Study Resources for Unit 1, down to the lecture note outlines, we'll be doing the fraction review PDF. Right, so that's like on all my videos. If you want something printed off so you can work on it while I'm working on it, that's what you do. Get into Blackboard, get these printed off. And these are based on what I do in class. I'm not going to have time to work every example. And in general, one thing I do is Math Lab tends to be fairly decent with the skill progression. It's not as good with the concepts of why you're doing things, or like common mistakes, that sort of idea. So in my videos, I will try to kind of hit on those and let Math Lab do a little bit more of the skill practice. All right, so let's get into the work. All right. Let me double check, make sure I am recording before I continue. Yeah, all right. So to start off with fractions, we're going to just do a quick review of improper versus proper fractions. Our brains tend to like proper fractions and mixed numbers. Improper fractions, not quite so much, but unfortunately, when we're doing arithmetic with our fractions, we're going to want the improper fraction. So we kind of need to overdo this. All right, so first picture, pretty straightforward. Usually have problems with proper fractions. If you want a fraction for that, the top of a fraction is always what we're counting. In this case, we're counting shaded pieces. So there's 3 pieces that are shaded. And then the denominator is always the size of the fraction. Denominator, you can think of that as sort of like the equivalent of place value with whole numbers and decimals. Each one of these squares is 1/4 of the total. So there's 3/4. Like, so pretty straightforward. All right. So now what about, so when we have 2 or more figures that are shaded, this is when we need mixed numbers, because proper fractions are always less than 1. Then that's what, the numerator has to be smaller than the denominator. So once we get a whole object or more, then we have to go into this. So let's start with a mixed number. Mixed number is pretty straightforward. It has a whole number and a fraction. So you need the whole number for this picture plus the whole number for the fraction for the second picture. That's 1 fully shaded object. So that's 1. And then for this picture, there are 5 shaded. So we have 5 on the top. There are 6 equal pieces. So that's 1 and 5/6. Okay. So just remember, when you have mixed numbers, that 1 5/6, we say 1 and 5/6. That actually means 1 plus 5/6. All right, so good enough. It's usually the improper fractions that we have issues with that we have to talk about. And so when you're doing improper fractions, you're going to need a denominator and a numerator. Right? And I usually get 2 answers on this, so let's go through both of them. So on the top, it's the numbers that are shaded. So there's 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5. So 6 plus 5. That gives us 11 shaded pieces. So 11 is going to be the numerator. It's the denominator that tends to cause problems. At this point, if I was doing this in class and get feedback, I'd get either 11/6 or 11/12. There is the most common answers. So they can't both be correct. Okay. So let's start with the 11/12. So when I see 11/12, to me, that's a proper fraction because 11 is smaller than 12. That tells me we're dealing with one object. It's one object broken up into 12 pieces, and we're shading 11. we don't have one object, we have two objects. So right off the bat, that tells me it can't be 11/12. So 11/6 is the right answer. Why is that the right answer? Well, the denominator is the size of a single piece in a single object. So that piece is 1/6 of the triangle, that piece is 1/6 of the triangle, that piece is 1/6, that piece is 1/6. Every one of the smaller triangles is 1/6 of the triangle it's in. So denominator is a sixth. All right. So mixed number or mixed numeral is 1 5/6. Improper fraction is 11/6. Now, if you note, the denominator is the same in both of those, which it should be. And that's going to help us when we start converting back and forth. All right. So when it comes to converting between mixed numbers and improper fractions, main reason we're going to do this is occasionally when you're doing your doing a problem, you're going to have a mixed number. And if you have to do arithmetic on a mixed number, if it's multiply or divide, you have to convert those mixed numbers to improper fractions first. Theoretically, there's a way to multiply and divide those, but we don't teach students how to do that, so it's never done correctly. So you have to convert them to improper fractions first. If you're if you're adding, subtracting, it's sometimes you can get away with just doing the fractions with fractions, whole numbers with whole numbers, but it can get messy. And so I'll show you that when we get into it a little bit later. So just anytime you're dealing with mixed numbers, doing operations, when in doubt, convert them to improper fractions, do your operations, and then you usually have to convert the answer back. All right, so how do we convert 3 5/6 to an improper fraction? So we need a numerator and denominator. And so what should automatically happen is the denominator will never change when you're converting from one form to the other. So we're starting with 6, we're going to stay with 6. And what we need to figure out is how many 6s total we have. So to do this, you need to do the division that's inherent in that fraction. Oh, no, sorry, that's the next step. Well, I'm ahead of myself. So how many 6s do we have? Well, to get that, you're going to do the whole number times the denominator. 3 times 6 is 18. And so that is, if you come back up to here, if we had 3 and 5/6, that would be 3 fully shaded objects. First one would have 6 pieces, the second would have 6 pieces, third one have 6 pieces, so that's 6, 12, 18 that are fully shaded. So that's what that 3 represents, is 18 pieces. And now how many other shaded pieces do we have? Well, 5, so you just add those. So that gives 23. So that gives us our new number. So 3 5/6 is equivalent to 23/6. In math, when we say equivalent, we mean it's not, it can look different, but it has the same value, basically. All right, so that is mixed number to improper fraction. How do we go the other way? So how do we start with an improper fraction and go to a mixed number? Well, for a mixed number, we need a whole number, a numerator and denominator. And one thing that we should know right off the bat, without doing any math, is that we're talking about thirds, so we're still talking about thirds. Okay. So how do we get the whole number part? So to get that whole number part, basically you're going to do the division that's there. All right. So for smaller numbers, you should be able to do that by hand, but you always have your calculator as a backup. So 19 divided by 3 is 6 point something. Now we don't want the decimal points because we're dealing with fractions, so we just need the whole number part. And so, the way you do this by hand, if you haven't done it in a while, 6 times 3 is 18. We can't use 7 because 7 times 3 is 21. It's too big. You subtract, we get 1, and that 1 is our remainder. So 19 third, or 19 divided by 3 is 6, and remainder 1. So how does that give us our improper fraction, or sorry, mixed number? Well, the whole number part of the answer is the whole number part of the fraction. And then the remainder is the numerator. So that 6 remainder 1 gives us 6 and 1/3. Now, if you notice, how do we check that to make sure it's right? Well, you basically just go in reverse order. 6 times 3 is 18. 18 plus 1 is 19. So when you're converting back and forth between mixed numbers and improper fractions, you're doing the same process, just what you're starting with determines which order. All right. So again, the main place we're going to use this is when you are doing arithmetic with mixed numbers, and we're going to convert them to improper fractions. All right. So something that causes some issues sometimes with fractions is simplifying fractions. And so, in class, kind of have a whole spiel we kind of go through talking about the English language versus the math language. So like if I ask you to simplify 20, 30 seconds, and how do we do that? Very often I get answers like, well, I'm going to put it in lowest terms. Well, what does lowest terms mean? Because to me, lowest terms means, if I have 20, 30 seconds up on the whiteboard class, then I'm going to, go down to near the floor, right? 20, 30 seconds. That's going to be the lowest terms. Or sometimes people will say, well, I'm going to put it in smallest terms. Well, if I want 20, 30 seconds in smallest terms, there it is in smallest terms. It's still not simplified. All right. So one of the problems I think we have with our math education is we don't make students use the math language. We let you use English. English is a fuzzy language. Math is not. So if you know something in math, but you only know it in English, it may not help you actually do the math. So one of the things I'm going to do this semester is try to get you more used to using the math language. And that's the problem, that's the language that all your problems are going to be written in. So it is helpful to get used to the precision of math. So if you're going to simplify or reduce a fraction, we tend to use those interchangeably. You divide the numerator and denominator. I'm going to abbreviate those by all the common factors. So what do I mean by that? Well, factors are the numbers that you multiply to get the number in question. So the factors of 20 could be 2 and 10 or 4 and 5. And 32 has its own factors. And we're going to divide the top and bottom by what they have in common. So like if the top has a factor of 5, the bottom doesn't, I can't divide by 5. That's going to change the number. All right, so let's start with this 20, 30 seconds. So there are a couple different ways to simplify it. So let's start with way number 1. All right, so when I ask in class, what do you see that's common to both of those? Typically get 2 answers. One of them is 4, one of them is 2. All right, so let's start with the 4. Okay, so if you see 4, this is what we call the biggest factor, or the greatest common factor. Right, so there's a lot of ways you could write your simplification. For the notes, I'm going to write it out fully so you can, if you're going backwards and watching this, you kind of see what we're doing. So 20 divided by 4 is 5. 32 divided by 4 is 8. Okay, so now we have our factors. How does this help us? Well, 4 divided by 4 is 1. Okay, so we divide that 1 out, and what are we left with? We have 5/8. Now, is that fully simplified? Well, 5 is one of our primes. 5 does not go into 8. So there are no common factors anymore. Which, speaking of primes, you're simplifying fractions, it's helpful to refresh those. Now, you could argue whether or not 1's a prime. It doesn't get us anywhere by calling it a prime. So I'm going to start with 2. Now, 2 is the only even prime because every other even number can be divided by 2. That's why it's our only even prime. So 3 is prime number, 5 is prime, 7 is prime. Now you might start thinking, well, 9 is prime, all our odds are prime, but 9 is not because 3 will go into 9. And then 11 is prime, 13 is prime, 15 is not because it's 3 times 5. So, 9, 15, those are what we call composite numbers. Because they can be divided by something other than themselves. Then we have 17 and 19. So those are your primes less than 20. So typically for the problems we do in this class, usually, people are good for checking 2. It's easy to see if they're both even. People are good for checking for 5 because it has to end in 5 or 0. But then a lot of times people stop, so don't forget to check 3, don't forget to check 7. Sometimes 11 and 13, usually by the time you get to 13, you've found most of the primes in these problems. Sometimes you have to go a little bit bigger. But it's that will help you simplify some of your fractions. All right, so back to that simplifying. And so what we did first was we divided it by the biggest factor. That was nice because it only took 1 step, but now let's do it again and divide by 2. And again, there's multiple ways you can write this. So I'm going to divide by 2 that way. And so 20 divided by 2 is 10, 32 divided by 2 is 16. And so here's where you get in trouble sometimes. This is what we call partially simplified. Which means we have simplified, we've divided a common factor, but not all the common factors because those are still both even. So we can divide by 2 again. And that gives us right back to our 5/8. Okay. And if you notice, we divided by 2 2's, 2 times 2 is 4, which is what we did in the first place. And so why would we ever do this instead of dividing just by the biggest one? Well, if you're looking at it and you don't see the biggest number that goes into both, it's if you can't divide by it. So a lot of times you just have to start somewhere, start dividing, keep dividing by 2 until you can't divide by 2 anymore. If you see 5, go with that, and then check your 3, check 7, check 11. Usually by then you've got it going so that you can simplify. All right, but what happens if you look at these numbers and you can't see anywhere to start? Okay, this is where factor trees come in. Or the fancier term is prime factorization. So if it's been a while since you did this, basically we're going to take 20, we're going to break it down, we're going to take 32, and we're going to break it down as a product of primes. And it doesn't matter really where you start, it matters where you end. So for 20, you could do 4 times 5 or 2 times 10, either way. I'm going to do 2 times 10. Now we're not done because 10 is not prime because it can be broken down as 2 times 5. Now those are prime, so we're done. Now I know a lot of you have probably been taught that once it's prime, you don't bring them down anymore. I prefer that you bring it down all your primes because each row should multiply to give you the original number. Plus, if you don't bring it down, you might lose it. So there is 20. Now for 32, it's 2 times 16, 4 times 8. I'm going to do 2 times 16. And if you wanted, you could say 16 is 2 times 8. Same time, I'm going to do 4 times 4. Bring down the 2. And then both 4 is 2 times 2. So now we have 32 working down to a bunch of primes. And so what do we do with that? Well, go back up to our fraction. We now know 20 is 2 times 2 times 5. We know 32 is 5 2's. So how does this help us simplify this fraction? Well, remember, our goal is to divide the common factors. And the nice thing about factor trees, yes, it's a little bit more work, to start with, but it takes all the guesswork out of it because now you look at this, well, we have 2 divided by 2 is 1. Okay. Then we have several more 2's. And it doesn't matter where it's in top and bottom. They do not have to be straight up and down. They don't have to be diagonal. It's just anything in top can potentially reduce with anything in the bottom. So I'm going to do this 2 and that 2. Okay. And then there are no more factors that are common top to bottom. So the top has a 5, the bottom has 2's, and that's it. So then you multiply what you have left, gets us right back to that 5/8. Okay. So this is sort of like the default method. If you didn't have our next method and you get stuck, this is how you would do it by hand. All right. So the last way, yes, and I know this might seem like overkill on this one fraction, but there's a method to my madness. All right, so let's say you know, whether it's a test or anything, you get to this and you just you blank, you have no clue, what is, how to get started. So how do you do this? Well, don't forget that this course allows you to use a calculator. And so one thing that you need to do, particularly if if you're a little iffy on some of the fraction stuff, make sure that whatever calculator you're going to be using for the test, that you also use for your homework, so you figure out how to do that ahead of time. All right, now my favorite, and I mentioned this in the syllabus, is this TI-30XS multi-view. The reason I like these is I think they're more fraction friendly. For those of you that have graphing calculators, actually, I don't think they're as fraction friendly. You have to hunt and search to get the fractions on that. But this calculator, that N over D button, that is our fraction button. If you look above it, it might be hard to see. It says capital U and then ND. That's a mixed number. So some calculators default starts as a mixed number. This one starts as a proper improper fraction, which I think is a little bit more useful. Now, how do you put 20, 30 seconds in there? Well, you could either type in 20 and then do the button and notice it makes the fraction, or you could start with the N over D button. So just use your fraction bars. And so put 20, and then over here with the arrows, arrow down. So you have 20, 30 seconds. You don't have to move the cursor over, it's a good habit, and hit enter. And so when you hit enter, notice it gives me 5/8. Now, if you're doing that and your calculator gives you a decimal, it's probably because of the mode that the calculator is in. Now, all calculators are different. This one's pretty straightforward. If you go to the mode button, on that last row, it says classic and math print. See how math print's highlighted? Math print for this class means the default your calculator is fractions, and we get to radicals, square roots, it'll default to square roots. All right. Then we can do second quit, get back to this. Now, what if you need the decimal, or what if your calculator is giving you decimals and you need the fraction? Well, again, these calculators right above the enter key, there's that double arrow. Notice when I hit the double arrow, it takes that fraction to a decimal. The double arrow again, takes it back and forth. Some calculators have an S arrow D button. I think it means standard to decimal. And so that button does the same thing this one does. Okay. So whatever calculator you have, make sure that you can do your fractions with it. All right, suppose I give you 17/49 and say simplify that. Well, if you're going through, trying to find something and thinking it may not simplify because you're having a hard time with the 17, well, your instinct's right. It doesn't simplify, but how do we know for sure? Let's put in the calculator. 17, arrow down, 49, hit enter. Notice that it gives me the same fraction back. So if you put the fraction in your calculator and you hit enter and get it back, that means it is simplified. By the way, the reason that is already simplified is 17 is one of our prime numbers, so it doesn't break down. 17 times 3 is 51, so 17 doesn't go into 49. Okay, so I expect you to be able to do like these basic 2-digit numbers. But what if I'm going to come back to number 7? What if we have that 396 over 468? How are you going to simplify that? Well, if this was like a lower level class, I might make you do one of these by hand. But honestly, the process is not any different for that than it is the ones we just done, just a lot more tedious. So I would personally even just grab a calculator on these 3-digit numbers. So if I do 396 over 468, bam, there we go, 11/13. All right, so as far as I'm concerned, that's perfectly acceptable how to do this type of problem. Oh, and by the way, for those of you that are printing these off and going through it, if you want answers on any of these, the answers are in Blackboard, the last page. So you have the access to those. Let me back up right quick to number 7, that -14/16. how does that negative impact the simplifying? Well, if you're getting comfortable with the fact that simplifying means divide the numerator and denominator by all common factors, what that means is that negative on the outside, that has nothing to do with the fraction. I'm starting with a negative fraction, so we're going to end with a negative fraction. Yeah, and the next lesson is dealing with negative numbers, and we'll talk about this a little bit more detail, but for now, it's still going to stay negative. And then what do you do with this? Well, ignore the negative. 14/16, those are both even, so you can divide them both by 2. 7 divided by 2, or 14 divided by 2 gives us 7. 16 divided by 2 gives us 8. And it's a negative 7/8 because of that. We started with the negative. All right. How about this 60 over 300? So yes, theoretically you could grab a calculator, but one thing when I see this, they both end in zeros, which means we can divide them both by 10. Typically what we do is we cross out the zeros on, 1 0 on each end. That means we're dividing by 10. So then we're left with 6 over 30. Okay. So here's where you might have to be careful, because you might look at that and your brain says 30 divided by 6 is 5, so the answer is 5. But we're not doing 30 divided by 6, we're doing 6 divided by 30. So what we're actually doing is probably need to divide them both by 6. Still keep it the same way we were before, and that gives us 1 over 5. So there's a big difference between 5 and 1/5. Now, if this was the other way around, and it was 300 over 60, again, if you wanted, we could divide both of them by 10 and get that 30 over 6. Now, when you have an improper fraction, particularly if there's a small number on bottom or a relatively small number on bottom, I would go ahead and do the division. I would do 30 divided by 6 just to see if it's a whole number. Sometimes it is, sometimes it isn't. If it's not, then you got to simplify it just like we have been. Now, I'm going to go ahead and do it that way for this example. So we know we can divide them both by 6, which gives us 5 over 1. Now, if you stop here, we will count it wrong in MATLAB. Because anytime you have a whole number over 1, you need to know to take it down to just the whole number. Okay, so 1 divided by a number, that 1 has to stay there. Dividing by 1, make sure to continue to simplify it. All right, and just a general note, in the homework, we're going to, particularly MATLAB is often pickier than I am. When it comes to the test, like if you had this problem and you left it as 5 over 1, I'd probably take off 1 point because you didn't simplify it all the way. But, to get down to the 5 over 1, you did the majority of the simplifying. So on the test, as long as you're showing work, I'm definitely great on partial credit because I'm more concerned about how you get there necessarily than what the answer is. All right, so that's simplifying. So from here on out, any answer that you have that's a fraction needs to be simplified. If it's not simplified, it's not. I would call it wrong. I would call it incomplete. And so, MATLAB's going to count it wrong. Okay, so how do you multiply fractions? Let's get into some operations. If I give you A over B times C over D, how do you multiply those? Well, when you're multiplying fractions, multiply top with the top, bottom with the bottom. It becomes one big fraction. So it becomes A times C over B times D. And you need to simplify at some point. Now, most of you have probably been taught to multiply first, simplify second. I teach it the other way because if you simplify first, then you're dealing with smaller numbers. And I'll do an example to kind of show you what I mean there. But also know that if you've been doing it the other way for most of your life, it's going to be hard to change. Now, how do you divide fractions? So if you have A over B divided by C over D, at this point, sometimes you hear about the cross multiply. Technically that works, but we should really say cross multiply for proportions, which we're not going to get to for a couple of weeks. So if you're using a cross product, there should be an equal between your fractions. And the reason I don't like to teach it that way is because, again, that's one of those things that a lot of people memorize, but they don't know why they're doing it. And so they end up using it in the wrong spot and don't know why. So I avoid talking about the cross product here. So, and I'm not generally big on mnemonics, but one that I think a lot of people tend to know is the KFC, the keep, flip, change. So if you're dividing fractions, you're supposed to flip the second fraction, the divisor, and then you make the divide a multiply. So it becomes A over B times D over C. Okay, so don't flip the first fraction, flip the one you're dividing by. And then once you do that, you're right back to a regular multiply problem. And at some point you need to simplify. And so as far as I'm concerned, I never divide fractions. I only convert it to a multiplication problem and go from there. All right. So let's do a couple of these. So 12 is 5/12 times 80 over 4. And again, I want to do this a couple different ways to kind of show you when I can. I'm not big on you have to do it my way. I want you to do it the way that works for you. If you have a way that's slightly different than I talk about in class, that's fine. But if your way is not consistently working for you, then I suggest you try it my way. All right, so let's just multiply this. Okay, so we're going to do 5 times 84. And yes, I am grabbing my calculator. That's perfectly acceptable. So it's 420. 12 times 20 is 240. All right, so now you have to simplify. That's a 3-digit number. Yes, you could put it in your calculator, but if you're multiplying first and get those big numbers, I don't have as much sympathy because I'm trying to get you to simplify first. But just know that we could simplify that from there. Let's see what happens if we simplify first. All right, so if you're simplifying first, remember that we're dividing common factors top to bottom, okay? And remember, this is really one big fraction once you multiply it. So when you're simplifying, it doesn't matter where in the top and bottom it is. It can be straight up and down or it can be diagonal. Very often the way these problems are written is it's diagonal simplifying, but it doesn't have to be. All right, so when I look at this, the thing that jumps out at me is that 5 and the 20. Obviously, those are both divisible by 5. Divide that by 5, divide that by 5. And right, this is one big fraction. So 5 divided by 5 is 1. 20 divided by 5 is 4. Now, when you look at the 12 and 84, and since those are the numbers we haven't simplified yet, is there anything that will simplify those? Yeah, they're definitely both evens. We can divide by 2. Often I hear 4 in this case, which 4 will divide both. If you're not sure, always go to your calculator, do the division, see if you get a decimal. But let's go ahead and divide these by 4, since that's the most common thing I hear. So 84 divided by 4 ends up being 21. 12 divided by 4 is 3. And so I don't know about you, but I'd much rather deal with these numbers than 420 over 240. Okay. And if you look at it, is there anything we can simplify again? Well, 3 goes into 21. Divide both of those by 3. So we get 1 times 7 over 1 times 4. Now there's 7's prime, 7 doesn't go to 4. So it is fully simplified. And we really don't have any multiplying to do because we're just down to 2 numbers, one top and bottom. All right, so I don't know about you, but to me, and I've been practicing this for many years, this is more straightforward than doing it this way. Even if you just partially simplify, like all you saw was the 5s, then you still have the 84 and 12. But again, that's going to be a lot smaller than the 420 over 240. All right, so just try to get in the habit, practice a little bit of when you're multiplying, simplify before you multiply. It should make your numbers a little bit easier to deal with. All right, I'm not going to do 13 all the way. Actually, let's talk about it. I'm not going to write anything down. So first of all, what does that negative do? Well, negatives are officially our next assignment. So, if you have a negative times a positive, most people remember the multiply rule, so we do know the answer is going to be negative. And when you look at this, if you think about simplifying first before you just jump into it, yeah, at 7, that's a prime number. 7 doesn't go to 8, 7 doesn't go to 13, so we can't simplify the 7 at all. If you look at 17, you might recognize that as one of our primes. 17 doesn't go to 8, 17 doesn't go to 13. So there's nothing here that'll simplify. So this is really just a multiply problem. So whatever 8 times 13 is, 4, over 7 times 17, so times 17 is 119. The answer is negative because we have a negative times a positive. So if you get in the habit of simplifying first, then actually I think it helps with the multiplying as well. And now if you simplified first, I don't even have to look and simplify this because if it doesn't simplify here, it's not going to simplify here. All right, I'm going to come back to 14. Let's look right quick at 15. So how do you multiply 3 fractions? Well, you could multiply the first 2, get an answer, and then multiply by the third one. But in reality, when you're multiplying a bunch of fractions, treat it as one big problem. So remember, anything in the top could potentially simplify with something in the bottom. I don't know about you, but those 11s are really jumping out at me. I'm going to divide both of those by 11. The other thing I see is the 6 and 16 are both even. So I'm going to divide those by 2. So what do we have left? Well, on the top, we have 1 times 1 times 3. On the bottom, we have 8 times 7 times 1. And now, is there anything else that can simplify? Well, 3 is the only thing in the numerator. There's no factors of 3 in the bottom. So this is just 3, and 8 times 7 is 56. 3/56. All right. And I really like to be able to pause and say, are there any questions? But obviously, I can't. This is not live, so we'll have to continue. All right, and again, when I'm putting this in the video, I will do timestamps so you can find the different things. I don't think my timestamps will translate to like the timeline on the video itself, but it will be like below the video. All right, so let's look at that 14. So we have 2 and 5/8 times 6 and 2/5. All right. So if you just try to do 2 times 6 and 5/8 times 2/5, I guarantee that you'll get a wrong answer. It is more complicated than that. The reason being that's 2 plus 5/8 and 6 times 2/5. If you wanted to do it that way without improper fractions, you'd actually have to FOIL it. If you know what that means, great. If not, we'll talk about that later in the semester briefly. But basically, if you're multiplying mixed numbers, you have to change them to improper fractions first. All right, so 2 and 5/8. Remember, the denominator doesn't change. So how do we get the numerator? 2 times 8 is 16. 16 plus 5 is 21. 6 and 2/5 stays fifths. And then 6 times 5 is 30. 30 plus 2 is 32. All right, so now we have a straightforward multiply problem. Yes, you could multiply them, but I don't know about you, but I'm seeing that 8 goes into 32. So I'm going to divide both of those by 8. 4 multiply, that would give me 21 times 4 over 1 times 5. And now you can see, since we have a 5 in the bottom as the only factor, 5 doesn't go to either of those. So now we can just finish the multiply process. So that would give me 84/5. Now the question is, are we done? So This is a simplified fraction because there are no, other than one, there's nothing that will divide into both of those. But this is where you have to read the instructions in MATLAB. When you're dealing with fractions in MATLAB, the instructions for the problem, like by the answer box, will either say, generally say, write the answer as a simplified fraction, or it'll say, write the answer as a simplified fraction or a mixed number. If it does not mention mixed numbers, 84/5 would be the final answer. If you try to convert it to a mixed number, it would count it wrong because it's not looking for it. In general, from what I've seen, is typically if the problem starts with mixed numbers, they're going to want the answer in mixed numbers. If the problem starts with proper and improper fractions, then they want the answer in proper and improper fractions. All right, so step one, we converted. Step two, we did our multiply and simplify. And now, since the instructions on this are most likely going to be, have mention mixed number, we got to convert it back. Okay, and how do we do that? Well, we know we're dealing with fifths, so that stays the same. And so now we need our whole number and our numerator. So this is, yes, this is a little bit bigger number. Go in your, we're doing 84 divided by 5. Perfectly acceptable, get in your calculator. So 84 divided by 5 is 16.8. Remember, we don't want the decimal part. We want the whole number part. So we just take the 16. What do we do with that? Well, 16 times 5 is 80. So that, when we subtract that, that leaves a remainder of 4. So for 84/5, that 16 becomes the whole number, and that 4 remainder becomes the numerator. Now in MATLAB, if you didn't take it all the way down to 16 4/5, you would definitely get it counted wrong in the homework and the quizzes. If this was a test question and you left it at 84/5, I'd probably take off 1 point because you didn't fully follow the instructions. But if you got down to 84/5, you did most of the work. And again, I always grade on partial credit if you're giving me steps that lead towards the answer. All right. So for multiplying mixed numbers, convert them to improper fractions, do the multiply and simplify, generally convert them back. All right. All right, I'm going to skip 16. Let's go to 17. So how do we do 4/9 divided by 9/5? I'm curious how many of you out there are thinking, well, I got 9 on top and 9 on the bottom, so we can just cross those out, simplify it, and we're left with 4/5. If you're doing that, you're treating this as a multiply problem. But when you are dividing, do not simplify a division problem. You can only simplify basically multiplication problems and add and subtract problems. So the first thing you have to do is keep the 4/9, flip the 9/5 to become 5/9, and now it's a multiply problem instead of divide problem. So can we simplify or cancel out those 9s? Well, the answer is no, because they're both on the denominator. Or if they were both on the top, they have to be one on the top, one on the bottom, but they're on the same side. So in this case, there is nothing to simplify because 4 is 2 times 2. There's no, 9 is 3 times 3. So there are no common factors at all in this. So once you flip it, the second one, this is just a multiply problem of 20/80. All right. So in the interest of time, I'm not going to go all the way through 18. I just want to talk you through how to set it up. So if we have 1 6/7 divided by 1 5/8, how do you do that division? So just like a multiply problem, convert it first. So 1 6/7 is how many sevenths? Well, 1 plus 7 is 7, plus 6 is 13. And then 1 5/8 is how many eighths? Well, 1 plus 8 or times 8 is 8. It's 5 is 13. So One thing I would recommend for a division problem with mixed numbers, very often I see students try to do the conversion and the flip at the same time, and then they tend to make mistakes. So I would highly recommend you convert first and then flip. The other thing is you cannot flip a mixed number because that whole number has to be part of that flipping process. If you're just flipping the fraction, you're ignoring it and you're guaranteed a wrong answer. And then the next thing we would do is keep the 13/7, flip the 13/8 to make 8/13, make it a multiply problem. Now we have 13 divided by 13. So we have 8/7. And so are we done? It is simplified because 7 won't go into 8. But again, we started with improper fraction, or sorry, mixed numbers. So most likely MATLAB is going to mention mixed number in the instructions. So the final correct answer would be 1 1/7. All right, so in a nutshell, let's multiply and divide. And one thing I would like to point out as a quick pause, we have not mentioned common denominators at all for simplifying, multiplying, or dividing because we did not need them. And so very often in arithmetic, add, subtract has different rules than multiply and divide. And so same with fractions. So when you're adding, subtracting, you do have to have the same denominator. In this case, the official term is like denominators. And the reason being is you can't add and subtract numbers that are different relative size. What I mean by relative size, the best example is place value. So if I give you a set of numbers, 312 plus 4 plus 78, and I say add those, and you're doing it by hand. I don't know about you, but what I'm going to do is line them up vertically like this. Well, why do we do that? Well, what that does is it puts the ones with the ones, the tens with the tens, and the hundreds with the hundreds. So you're adding the same place value. If these were decimal numbers, you would line up the decimal number or decimal points for the same exact reason. So then not only you line up your whole number place values, you're lining up your decimal place values. Because you're going to only add tens to tens, you can only add hundreds to hundreds, etc. So in fractions, the denominator is the equivalent of place value. So we can only add fifths to fifths, thirds to thirds, 30ths to 30ths. They have to be the same denominator. And so how do you add like fractions? So if I have a over b plus c over d, or sorry, c over b, supposed to be the same denominator. Well, do not change the denominator. Do not add or subtract denominators. If it's the same denominator, keep it the same, and then you just add or subtract the top. And then, as always, simplify if needed. Okay. If they are unlike denominators, you need to get your LCD, which is your least common denominator. And then you need to convert your fractions to the LCD. That way they'll all have the same denominator, then you can do your add subtracting. We're going to go over that part, but it's usually that second step of the conversion where mistakes are made. All right, let's do a couple basic ones before we get into the messy ones. So 2 nights plus 4 nights, how do you do that? Well, they both have 9 on the bottom, so that's our denominator. 2 plus 4 is 6. Now, most students aren't going to write this step, particularly a problem like this, but for the notes, again, I'm going to write out every step. Are we done with this problem? Hopefully you say no, because you always have to check if we can simplify. Both of those are divisible by 3. So our final answer would be 2/3. Works the same for subtraction. There we're going to do 13 minus 9 over 14, which is 4 over 14. Those are both even, so we can divide by 2 and get 2/7. There we go. If the denominator is the same for subtracting, that's much more straightforward. I'm going to save 22 until the next lecture because that's we haven't talked about integers yet. Let's look at number 23. How do you abstract multiple fractions? Well, again, they all have the same denominator, so we can actually just put this all over 35. Now, if you have multiple fractions like this, it might be easier to go ahead and write, or it might be helpful to write that step of what you're doing on top. So we are doing 20 minus 4 minus 2. Yeah, and then that gives us 16 minus 2 or 14 on the top. Again, you have to write out every single step just for the notes. I'm going to try to write it extra. And then as always, ask yourself, is that simplified? If you can't see anything, it doesn't hurt to put in your calculator just to check and see. This one, they are both divisible by 7. Our final answer would be 2/5. So if you're extracting multiple fractions, just again, treat it as one big fraction basically, and then kind of go from there. So those are like fractions. All right, so what about if we have unlike fractions? All right, so this 3/5 plus 1/25. And so they have different denominators. So we need to find that least common denominator. So what is that least common denominator between 5? Sorry, my 5's all my guesses, and 25. If you're looking at that and thinking 5, what you're finding is the greatest common factor, which is basically the exact opposite of the least common denominator. So the greatest common factor is the largest number that will divide into both. So 5 will go into 25, and then so there's nothing bigger than going to 5, so that's the GCF. But that's basically the exact opposite of what we want. Because the LCD, the least common denominator, is the smallest number they will divide into. We don't care what divides into them, we want to know what do they divide. And here's a tip. Always check your biggest one. And a lot of times your biggest denominator is your LCD. And since 5 does go into 25, that means that's the smallest number. 25 is the smallest number, both of those will divide. All right. So what that means, so now we need to get 25 on the bottom of both of these and do it correctly. So we need to convert 3/5 to something over 25. And the 1 over 25, it already has 25 on the bottom. So that there's no extra work on that. So what do we do with 3/5 to get 25 on the bottom? Well, 25 divided by 5 is 5. So we have to multiply the bottom by 5. And here's where the majority of mistakes are made, is you can't just multiply the bottom, you got to multiply the top. Basically, we're simplifying in reverse. If you have 5 divided by 5, that's 1. So you're essentially multiplying this by 1. It means you're not changing the numerical value. You're changing how it looks, but not the value. If you're just multiplying the bottom by 5, you're no longer multiplying by 1. You're totally changing that number, totally changing the problem. Guaranteed wrong answer. All right, so 3/5 is equivalent to 15/25. Now we have a common denominator. Now we can just add the tops. So it gives us 16 over 25. Can that be simplified? Well, I'll just do a quick rundown. 25 is 5 times 5. 5 will not go into 16. So yes, that is simplified. So when you're adding unlike fractions, first check your biggest denominator. That might be your LCD. All right, next problem is 1/6 plus 2/7. 25 in the handout. So what is the LCD here? Well, if you look at the biggest one, 7, 6 does not go into 7 evenly without a remainder. So now we need to go bigger than 7. Now, there's a couple ways that you can do this. In general, one way that you can find LCDs is start listing multiples of your numbers. I always like to start with my biggest one. And so when I say multiples of 7, I mean 7 times 1, 7 times 2 is 14. 7 times 3 is 21. And what you want to do is just start listing these numbers until you find something that's in common. So list a few, and then go back to 6, start listing its multiples. So 6, 12, 18, 24, 30, still nothing in common, 36, 42. Oh, and there we go. So 42 is that smallest number that the multiples both have in common. So that's why sometimes you'll hear the LCD referred to as LCM for least common multiple. Now, if any of you are out there saying, well, why don't we just multiply 6 times 7 and get 42? That is one way, if you're multiplying denominators, that guarantees you a common denominator. Which to add subtract, all you really need is a common denominator. If you don't have the smallest one, basically that means you're going to have more simplifying to do. So if we back up on this problem, if we multiplied 5 times 25, we would have 125. And so if we're doing 125 on the bottom, you can see the numbers can be a lot bigger. So we have to multiply this by 25 over 25, this by 5 over 5. And so when your numbers are bigger, you're going to have more simplifying in the end. But, if you look at 6 and 7, they have no factors in common. If they have no factors in common, you're just going to end up multiplying them anyway. 5 and 25 had a common factor of 5. That's why there was a smaller number than just multiple. But when in doubt, when you're adding fractions, you can multiply the denominators. All right, so we need to get both of these over 42. How do we do it legally? Well, on the 1/6, 42 divided by 6 is 7. So we're going to multiply top and bottom by 7. So that gives me 7 over 42. For the 2/7, 42 divided by 7 is 6. So we're going to multiply top and bottom by 6. So 2/7 is equivalent to 12 42. So now we have a common denominator, so now we can add them. They're both over 42 now, so 7 plus 12 is 19. And then we need to see if we can simplify. Turns out 19 is one of our primes. If you try to do 42 divided by 19, you're going to get a decimal number. So that is simplified. All right. Yep, so let's do subtraction. So if we look at 21, we have 5/11 minus 7. So how do we deal with this? Well, anytime we're dealing with fractions and whole numbers, it's generally going to be more straightforward if everything's a fraction. And how do you make a whole number a fraction? By putting it over. Yes. So we're really dealing with 5/11 minus 7 over 1. So the denominators are different, so we need an LCD. And what is the least common denominator? Well, always go with the biggest one, which is 11. 1 goes into 11, so our LCD is 11. We need both of these over 11. Well, 5/11 is already over 11, so we don't really have to do anything with that. For the 7 over 1, you multiply the bottom by 11, which means multiply the top by 11. Excuse me. We get 77 over 11. All right. This is looking ahead a little bit because we haven't talked about integers officially, but we do know this is over 11. And so how do you do 5 minus 77? When in doubt, always have your calculator as a backup. Now, just to give you a brief preview of next section, first of all, you have to figure out two things. One, are you adding or subtracting these numbers? And two, is the answer positive or negative? The 5 is positive, the 77 is negative. So when you're actually subtracting, if the signs are different, you're subtracting. It's basically the positive 5 says we're going right on the number line. The negative 77 says we're going left on the number. So if you're going opposite directions, you're subtracting. So 77 minus 5 is 72. Now, is it a positive 72 or a negative 72? Well, for subtracting, the bigger number controls the sign because we're going left 77. So we're going to definitely be in the negative. That's not going to simplify, so our answer would be negative 72 over 11, which you would also see that as negative 72 out front. Those do mean the same thing, and we will discuss that in the next video. All right. So last little bit I want to talk about with subtracting, we're getting close to the end of this, is mixed numbers. So if you look at 28, 5 and 7/9 plus 1 and 5/6, I'm going to say right now, if you're dealing with mixed numbers and your denominators are different, do not try to abstract the whole numbers and the fractions, separately. Convert that to improper fractions and then deal with the LCD just like we did before. With 9 and 6, if you're looking for the LCD, you could do 9 times 6 would be 54. That would be a common denominator. But if you start doing like your multiples of 6 and 9, they would both go into 18. So your LCD is 18. So I would convert those both to improper fractions, then convert them both to a denominator of 18, and then go from there. Let's do a subtraction problem. One that's a little bit more straightforward. So if you look at 10 and 1/8 minus 5 and 3/8, so these have the same denominator. So that's going to be a little bit more straightforward if we just keep them as mixed numbers. Now, typically, when we're abstracting mixed numbers, we write them vertically instead of horizontally. And now, don't do the whole numbers first. We got to deal with the fractions first. And so the question is, can we do 1/8 minus 3/8? And the answer is no, because 3/8 is bigger. So just like anytime you're subtracting, we're going to have to borrow. So as we go through this, if the borrowing part of this is throwing you off, then my recommendation, just convert these to improper fractions. You don't have to worry about like borrowing the fractions. But let me show you this just so you see it. So we're going to take 1 away from 10, make that a 9. Now, if this was dealing with regular numbers, whole numbers, we would add 10 to that. But I can't add 10 to this because I'm not dealing with tenths. Since our denominator is 8, we're going to add 8. If our denominator was 6, we would be adding 6/6. If it was thirds, we'd be adding 3/3. So that denominator tells you what you're adding when you do your borrow. So now what we have, let's rewrite this. We now have 9 and 9/8, because 1 plus 8, minus 5 and 3/8. Now we can do 9/8 minus 3/8, that's 6/8. 9 minus 5 gives us 4. And so without converting improper fractions, we did the subtraction. Is that the final answer? This still has to be simplified. How do you simplify a mixed number? We haven't talked about that. Well, actually, it's not that bad. Ignore the whole number, just simplify the fraction part. Okay. So 6/8, those are both even, so we can divide them both by 2. So that becomes 3/4, and then the whole number does not change. So it's 4 6/8 would be 4 and 3/4. Okay. I'm not going to do a big addition for mixed numbers, but I do want to throw out, let's say, for example, you were adding a couple of mixed numbers and you got for an answer 5 and 7/4. Because you're just adding the whole numbers to whole numbers, fractions, that's what you ended up with. If you put this in as an answer, it's definitely going to get counted wrong. And the reason being is this needs to be proper. Do not stop if you have an improper fraction when you mix number. Also, don't forget that this really means 5 plus 7/4. So what you have to do is convert the 7/4 to a mixed number. So if you do 7 divided by 4, it'll go in once. You'll have a remainder of 3. So 7/4 is the same as, or is equivalent to 1 3/4. Once you do that, now you can do whole numbers to whole numbers, and that would be 6 and 3/4. So if you're actually subtracting, theoretically, you can stay with mixed numbers. Like I said, if the denominators are different, I would recommend going to improper fractions. If the borrowing and carrying that we talked about bothers you, go to improper fractions and kind of bypass all that. All right, so that is adding and subtracting. Now, just a real minor thing, this comes up occasionally. How do you convert a fraction to a decimal? So how do we know what 17/20 is? This is something where we have a quick answer. That's this thing right here. So all you do is 17, you can, that fraction bar is a divide. So you do 17 divided by 20, that's 0.85. Now, do we need that 0 in front of that? No. Like when I'm doing my notes though, particularly when I'm writing on the board, it just makes it easier to read my notes if I put that 0 out front, so I'm always going to put it. Now, you can also do this as a fraction. Now, notice that it's going to give me back 17/20 because I'm in math print mode. Remember, if you hit that double arrow, it takes you to the decimal. Okay. So what about 40 over 20? 43 over 20. So again, you can do 43 divided by 20, but divide by instead of the fraction bar, takes you straight to the decimal, 2.15. What are you going to do with the 3 and 9/20? How do you convert that to a decimal? So the common answer I get in that in class is convert that to an improper fraction and then do what we did, which will work. But it actually turns out that that's more work than you need, because when we say 3 and 9/20, that and also means, not only does it mean plus, it means a decimal point. So that 3 for the mixed number is the 3 on the whole number part of your decimal. So really all you have to do for the decimal in this is do 9 divided by 20, just do the fraction part. That's 0.45. So 3 and 9/20 would be 3.45. All right, one last, do I have room here? One last fraction and decimal question. What if I give you 9/11? What is that as a decimal? All right, so 0.818181 forever. So how would you put that answer in MATLAB? Well, in general, MATLAB, does not, you can't put in decimal numbers that go on forever. So typically on a problem like this, MATLAB would tell you to round it to a specific place value. So like it said, round to the nearest hundredth, you would go to that, the hundredth is the first to the left one. And so that would round to like 0.82. Yeah, just whatever place value it tells you to round. But do you remember how to do this without rounding? Well, we have a repeating number. That 8181 is repeating. So if you ever see numbers with a bar over it, that's telling you that the 81, or whatever's under the bar, is repeating. For example, we have 4, 3, 3, 3, forever. The 4 is not repeating, so you just put the 4. The 3 is what's repeating, so the bar would just go over the 3. So you might see that occasionally. So just a notation that we don't use a lot. But if you ever need to convert a fraction to a decimal, just do the divide by instead of the fraction bar, put your decimal. All right, so we went through a lot. There's a lot of little things with fractions. And again, I can't emphasize enough that you practice fractions on your calculator. So that way you have it when you need it. So what did I not cover? One thing I didn't cover, this calculator defaults to improper fractions. What if you want a mixed number? So let's look at that 5 and 7/9 plus 1 and 5/6. How do you put that in the calculator? Well, for this particular calculator, the U n over D, the mixed number is above the button, so I need to do second, and shift. Now, once I do the n over D, notice that now I have a mixed number, not an improper fraction. So I can do 5, arrow over, get to the 7, arrow down, get to the 9. Now notice that cursor is still on the denominator. You have to arrow over to the right. So now I'll do plus. Now I need another mixed number, so I do second and then my fraction button again. So now I need 1, arrow over to get 5. Yeah, I need 6. And you don't have to, but I always like to move that cursor. So I'm trying to do 5 and 7/9 plus 1 and 5/6. I hit enter. Notice that it gives me 137 over 18, which is simplified because the calculator will give you the simplified answer. Notice that it's not not a mixed number. How do you do that? Well, you can either do it like we did before, or I don't know if it'll zoom or not. If you look right next to it, there's an N over D double arrow U N over D. So if I hit second and then that button, hit enter, tells me 137 over 18 is 7 and 11/18. So as a math teacher, do I want you doing all these fractions on a calculator? I'm going to confess and say absolutely not. But like the more you can do without the calculator with this basic arithmetic, the stronger your core skills are. But again, we don't have time to go over everything. You have habits over many years of dealing with math that we can't just change overnight. But try to use the calculator more as a backup, not your primary tool. But you are allowed to use calculators, so I want to make sure that you can use them correctly. And so again, please practice with your calculators as you're going through your. All right, so this concludes our fractions topic. And so have a good evening. If you have any questions, let me know.